Okay, it's 4 o'clock, so we'll go. Welcome to the last session of the day. Congratulations if you survived this long. You've probably seen these intro slides already, but I'm obliged to go through them. Developer is a community event. All the speakers have given their time for free. All the producers who are running the teams things have given their time for free. All the organization has been done for free. This doesn't exist without the support of both the community who provide the content and you, the audience, for coming to watch us. It is very much appreciated. There is a code of conduct. It says be nice. We are supporting, or DDD is supporting, the National Museum of Computing. If you haven't already, I would strongly advocate for you to go and add to the Just Giving there. There are a number of sponsors. DDD is not possible without its sponsors. This year, or for this event, obviously being virtual, it's far less of an issue than usual. And I'm given to understand that the sponsors are making donations to the National Museum of Computing on behalf of DDD, as well as providing the amount of support we have here. If you haven't already, you can go and find lots of stuff on social media. And there we go. So, cloud infrastructure as code in Pulumi. My name is James Murphy. I first put my hands on a computer, an RML 380Z in 1979. It had tapes, not disk drives at that point in time. I've been writing code and learning new things ever since. I get paid to be a cloud software engineer, whatever that means. And one of the things that I do as a cloud software engineer is use Pulumi. So Pulumi is a tool for defining infrastructure as code, programming language type source code. It's also a tool and a pay-for service for managing deployment of the infrastructure you define. This brings up some questions. First of all, what is infrastructure as code, or at least what am I thinking of infrastructure as code? Why is it a good idea? And if it is a good idea, why Pulumi? I shall attempt to answer that by asking a different question. What is it that we as software engineers do? At the most basic level, we find problems and deliver solutions to those problems. In my case, those solutions are deployed to and take advantages of the services provided by a public cloud, be that Azure or AWS or GCP or something else. This gives us a definition of delivering value that says we need a deployed solution available to our users. To be effective in delivering, we can take guidance from the experience of others. In Accelerate by Dr. Nicole Forsgren et al., we have very clear evidence that the time to go from committed code to deploy application correlates very strongly with high-performing teams. The less time it takes, generally speaking, the better the team is. This leads us to the principles in continuous delivery by Jez Humble and Dave Farley. One of those principles is that we build and package once and deploy to multiple environments as needed, but we always deploy in the same way, whether that be to the dev environment or to staging or to production. I could talk about this for hours and will happily do so over coffee or cold refreshing beverage later in the evening. But the key principle in this is that we automate everything. We automate things to make them trivially repeatable, and that has to include deployment. If you want to automate everything, then using a cloud web console isn't the answer. Trying to automate mouse clicks, especially given that they change the consoles regularly, is just not going to work. So how do we automate definition of infrastructure, or the definition of deployed systems, where in cloud terms there's considerable overlap? There are a couple of approaches. We could script things. All of the cloud providers provide REST APIs and command line tools to create and configure services. Unfortunately, we want our definitions to be idempotent. That is, we want to be able to run the script whether the services exist or not, and for the outcome to be the same. And that gets quite difficult quite quickly. Better would be to take the Picard approach, to define what our infrastructure should look like and tell someone else to make it so. This is more usually referred to as desired state configuration. The good news is that public cloud providers support this approach. They have declarative systems for specifying your requirements and engines that magically transform those specifications into cloud infrastructure. The bad news is that we very quickly end up with a wall of markup, be that JSON or YAML. This, and you can't read it, is the Azure ARM template for my sample system. It's nearly 400 lines long. The equivalent in AWS Cloudformation YAML would be a similar size. fundamental problem with these templates is that they're hard to read and therefore hard to maintain. There is a huge amount of duplicated boilerplate and not a small amount of arcane cleverness where programming concepts are brute forced into markup to overcome the limitations of just plain JSON. So the templates require you to understand not only the infrastructure you're targeting, but also effectively a whole new language used to create and configure that infrastructure. Coming back to our core problem, delivering value by making solutions available. There is a strong argument outlined in the excellent team topologies that delivery teams, which should be around 5 to 9 people, should own solutions end to end. If you write it, then you should deploy it and you should operate it. Key limiting factor on what an individual and a team can own and operate is how much cognitive load it can support. What can it comfortably think about without it falling out of your ears? Having to understand ARM or Cloudformation or the YAML for Google's Cloud Deployment Manager will consume a goodly chunk of that available all on its own and leave you less scope for your actual valuable solution. So we want something that's both more flexible than JSON or YAML and that is more easily understood by the developers on a delivery team. In other words, application source code. So if we're going to have code, we have some options. For AWS, Amazon provide the CDK. That targets multiple languages as well. For Azure, there is a very impressive farmer. It's an Fsharp DSL, what's not to like. And Microsoft are experimenting with a thing called Bicep. They're also doing some other things to make ARM nicer. Or there is Pulumi. Pulumi targets multiple services and lets you write code in multiple languages. You can write in Python, Go, languages that support .NET, and TypeScript. And that means it's probable that your team can define the system it wants to deploy using something it already understands. And that removes some of the additional load, leaving more time to think about the actual problem space rather than how to shave yaks. The other advantage we gain from having infrastructure-defined text files, whatever format, is that we can store that infrastructure with our application source code, and then we can see it evolve with the source code as we go along. So at this point, I think it's clear that, I think at least, that defining our infrastructure in a text file is a good thing. Makes deployment repeatable. It makes it possible to do it to as many environments as we want. It makes it trivial to deploy as and when we want. We currently run 6 environments for 4 developers. And we can use version control, which gives us a history and the ability to audit and control what we do. That audit point is quite important. If you have ISO 27001 that says somebody else has to review changes before they go live, a PR with a user is another person reviewing the code with change before it goes live. So on top of this, Pulumi gives us, just to start with, some degree of language independence. It doesn't have every single language, although I think they're planning on adding more. Gives us a service and a system for managing multiple deployments of the same system and a diverse system, and a useful level of target platform independence. When I say target platform independence, Pulumi is built on Terraform. Off the back of that, we have quite a lot of things that we can use. The core providers are the usual suspects of AWS, Azure, Google Cloud, and Kubernetes. But there are a lot more cloud providers, including Alibaba and DigitalOcean. Then there are things that are more infrastructure-like, so Auth0 for authentication, PagerDuty, Azure DevOps, and beyond that, there's support for databases and monitoring tools and networking and version control. Although I think that GitHub has gone some considerable distance beyond just version control, is far closer to a full development lifecycle tool. So I want to use Pulumi for everything. If you think about this in terms of onboarding and offboarding a developer or a technical specialist, being able to grant them the access and the privileges they need to the services that you use to do your job, simply by adding an email address to a list, is vastly better than having to run around half a dozen different services saying, I need to add a user, I need to do this, I need to do that. But also, you can use it for things like making your repositories set the same, so that they're set up in a consistent manner with equivalent rules for PR review requirements and who can make what changes when. So I could talk, as I said, all day about this, but enough about why. Really, what we do is show some how, and I promised some actual code, and I think that seeing code is important. So if we have an application that's something very vaguely like this, something that makes a request, looks to see if it already has the answer, if not, goes to a third-party service, pulls the appropriate data, transforms it into something that's useful to our systems, caches it in a data store, and then returns the result to your calling service. This is code that I've actually written in a former life. It's much simplified, but the concept is the same. For this example, I'm going to use a function to perform the service and a blob or S3 for storage. Probably one might use Redis as a cache rather than a file store, but it'll work. And as I said, this is based on a real system that I've worked on. So where do we start? Pulumi works from the command line. So we install by the appropriate means for your dev platform. It will install on Windows and on Macs and on Linux. Once installed, here's one I prepared earlier. I'm looking at over there because I can't see it. I have basically an empty repo with a little bit of initialization in. I'm going to make a new folder to build my Pulumi project in. I'm going to use Pulumi to template a new, sorry, my bad, I'm going to tell you that I'm running Pulumi version 2.10. They're currently up to 2.15. It revs quite quickly. Pulumi needs to store information about the things that you've deployed. It can do that locally in your user root, which is probably not a good idea. It can do it in a file in the directory you're in. So the second one there says log into the current folder and store the data there. That will work quite well with GitHub, probably won't scale. After that, I then use Pulumi to create a new project. So I've got a C# project. When I do that, I have to add in various bits and pieces, much like any other project. The Pulumi configuration will store secrets. Therefore, you need a passphrase to protect those secrets. Or you can use other ways to secure things. We use Azure Key Vault to protect our secrets. Once we've done all that, we end up with a .NET project that's pretty much like any other console project. And if I run preview now, and type my passphrase in because I have to protect our secrets, what you'll see is it will do a .NET build of my source code. Then it will work out what needs to happen. And it will say that it wants to create 3 resources. Because I want to have multiple stacks, what I'm going to do is I'm going to set a couple of, well, just one configuration value, I beg your pardon. I'm going to say that I want to deploy to dev. And if I look at the YAML file that Pulumi's created for the Azure dev stack, you see that I've got some configuration that says I want to deploy to dev, and I want to use Azure locally, plus a bit about decryption. We seldom want to deploy to just one place, so we'll create a second stack that will deploy to what we'll call Azure test. This time I want to set the deploy to test, so I've got 2 different places to put it. So there you can see I've got 2 stacks, and the asterisk indicates that the second stack is selected. Because I'm at the beginning, I want to start with the first one, so I'm going to select that back. And that's that demo done. I'm not going to deploy that as it stands because it's not really what I want. But let's at least see what the template created. First thing it did was create a class program with a static main int that does a bit of Pulumi magic to run a thing called myStack, and myStack is where the fun is. This is all of the code that was generated by the template. So going from the top, we create a resource group in Azure. Things that you create are kept in resource groups. The default name for a resource group is resource group. It creates a storage account with the standard parameters. It then sets a property on the class or to the primary connection string for the storage account. and that will then become the output. And when you run stacks, stacks can have outputs. Those outputs can either be consumed by you yourself personally, or they can be read as inputs into other stacks, so that you can chain stacks together. Yeah, I don't want to actually deploy that though. Before we do, I want to make a few changes. Template never matches what we need. So the first thing we'll do is give it a more sensible name. We'll call it Azure Stack. The second thing we're going to do is read load the Pulumi configuration, and from the Pulumi configuration we'll get the deploy to. Because we say require, the deployment or build will fail. The deployment will fail if that deploy to value doesn't exist in the configuration. Then we're going to change the resource group. So we'll change the resource group name to be something more appropriate, and we'll tack the deploy to onto the end. By default, Pulumi will generate a random name for your resources. It will take the name that you give it at the top and will add on 8 random digits. This is useful for avoiding collisions and ensuring that things can be deployed safely. Not quite so friendly from trying to work out which thing is what. Because of that, in this case, I've explicitly named the resource group just to make it a little easier to do things later on. And then because storage account connection string is not the kind of thing that we ought to be waving around, it's actually a secret. I've changed the output to just output the name. So let's actually run a deployment. This was the subscription I had for this demonstration before I run the deployment, and as you can see, completely and utterly empty. So now we'll actually go back to the command line and run the deployment. I gave myself a script to make sure that I've got the secret set and a couple of other bits and pieces that it needs to be happy, and that I've logged in correctly, excuse me. So first thing I do is just list the resource groups. There are none. So we'll do Pulumi up. Up is the command that you run to actually cause something to happen. First thing it does is show you a preview. As I said, it does a build and then it does the create. So at this point, it's going to try and create 3 things. There you go. Yes, I want to do this update. So it repeats the build. And this time it is actively creating things against or in Azure. This is hurry up and wait. This is the point where if I was doing this live, I would be praying to the demo gods. However, since this is one I prepared earlier, I know it results. And there you can see the storage account name has come out, and with the random value tagged on the end to make it unique. And then if we go and look at the groups, you can see I've got my new resource group. And if I look at the contents of that resource group, you can see that I've got the storage account. If I then go back to the Azure console, it lives, hooray. So how does Pulumi keep track? Well, it does use a wall of JSON, but it's not one that you need to worry about. You know it's there. If we take a brief look at bits of this, you can see it's named for the stack, that for each resource it creates a URN that uniquely identifies that resource within Pulumi, and then it takes the ID that Azure has used for the resource. So if I go into resource and look at the value off somewhere to the right there, I could find it. It tells you what the type is. Similarly, here's the one for the storage account. This is all stuff behind the curtain. You don't really need to, but if you want to, this is all committed to my to the repository for this presentation, and you can go and look at it, or you can just run it yourself and you'll see. That doesn't do anything useful. It creates a storage account. It doesn't do anything with it. So let's add something useful to the code. This is the function that we're going to deploy. This is the startup code for the function we're going to deploy. It's in Fsharp, but that doesn't really matter. What is important is that it takes some config values. So we need to know where the quote server is that the function is going to call. We need a connection string to get to our data store to our blob storage, and we need to know the container that we want to write the data into. I'm using the standard .NET configuration stuff. So I do configuration builder, add environment variables, and that means that when the function runs, it will look in environment variables for its configuration settings. So now we need to add those same resources to our stack. Firstly, we're going to have a couple of containers in our blob storage account. We're going to have one called zips, in which we're going to upload the packaged function code, and we're going to have the data container that the function is going to write to cache the values when it reads them. Next up, we're going to have a service plan, because if you want to run a function in Azure, you run it in a service plan. So we have a service plan, we give it the name, sorry, we tell it which resource group it's in, we tell it what kind of service plan it is, and the tier and the size means it's the consumption plan, so we only pay for invocations. As I said, the actual code that we're going to run in the function, we get by packaging up the standard publish folder for the function. So if I do .NET publish, I end up with the application code in the publish folder. That zips it up and then creates a blob in our zip container with that zipped archive in. And then I create a shared access signature for that blob that I can then pass to the function app when we create it. So I create a function app, resource group, service plan, and the settings. The most important thing here in the settings is that we're also defining the server host, the connection string, and the data container. And when we're defining these things, we are pulling the values back from things that were created earlier. Lastly, I add something extra to the output, which is the endpoint that has been created again using the host name that was generated for the app, so that I can go and actually test it from my command line. So all of that comes down to about 90 lines of code, which you might actually be able to read this time. So to achieve the same result as all of that JSON, I've got a quarter of the code and something that's far easier to read and understand. To be slightly fair, I could probably have got rid of some of the ARM if I was doing it from scratch. But as a C# or an F# programmer now, but as a C# programmer, this is much easier to understand. So let's deploy and run that. We do the setup again. Exactly as before, we're doing Pulumi up straight away. This time it says it wants to create 5, but it leaves 3 things unchanged. So I do want to perform this update because it wouldn't be much of a demo if it didn't actually, do anything. And we can see it creating the plan and the zips folder and the data, the zip container, the data container, and the Azure function. And lastly, the function app. The function app, unfortunately, takes a while to create. I suggest you talk amongst yourselves, but I can't see you, and you can't see everybody else. So we'll have to see how we go for that. Oops. Don't click on things. This is that wonderful paint drying moment. If you're a dev, you're just sitting here going, yeah, that's good. But in a demo, not so fun. What we can see here now, though, is I've created my data container. I've given myself an HTTPS URL that I can go and look at. And if I look at the resources, we can see that I've now got 3 resources in my resource group rather than just the one we had before. I can invoke that HTTP URL with some parameters I prepared earlier, and I get a Douglas Adams quote. change the parameters, I get a different Douglas Adams quote, and all the parameters are something like that: client ID, quote ID, and so on. The last thing I want to do in this case is run up the Azure test, and this time it's going to go from there are no resources at all, so we won't have leave 3 alone, create 5. We'll have create 8, and there we go. Off we run to create 8. I have to let that run because there's something at the end I need to show you. At least I think there is. I would have edited these down. These are actually already faster than they are in real life, but I would have edited them down, except that because we're doing crazy things with the characters, if I edit them down, it would probably break the rendering. We are at least creating it now. There's my function app. Hopefully any moment now it will say created. I'll cheat. When it's finished, we end up with 2 resource groups instead of 1, both with all the same pieces in, but 2 completely separate copies of. Still going. Yeah, and then we can see different HTTP endpoint. But if we looked at list the groups, we have 2 different groups rather than just 1. That wasn't much exciting there. Right. So that's creating something and deploying it to 2 separate instances, exactly the same code in Azure. So what does AWS look like? I followed the same process, created an AWS project using the Pulumi template, and that gave me this. It's even less complicated in that there's just a bucket and it just returns the bucket name, or bucket ID, beg its pardon. One thing here is this time where our using is pulling in AWS, whereas before we were pulling in Azure. So that's the difference between the 2. Pulumi is using different packages to achieve for each of the services it provides providers for. Okay. So let's add the Lambda to this stack. Exactly the same as for my Azure stack. I'm going to load the config, and I'm going to require that there's a deploy to environment. AWS doesn't have resources in the same way, resource groups in the same way that Azure does. It kind of does now, but it certainly didn't used to. So we want to explicitly tag things as we go along. We're not using Cloudformation stacks when we do this, so the resources are all being created independently, and we need to be able to group them together, otherwise we will go ever so slightly nuts. So we're just creating tags as a map with a tag name and some values. Then we're creating our S3 bucket. We're going to give it a sensible name, and we're going to add the tags to it. We're going to create a role, because AWS does love you to create roles, that will allow the Lambda role to execute, allow the Lambda service to execute. Oh, never mind. It's AWS, you have policies. Then we need a policy to allow the Lambda function to write logs to CloudWatch, because we like to see whether it's worked or not. And lastly, this is the interesting one. We need to have a policy that allows the Lambda function to interact with the bucket securely. But we don't know what the bucket is at the point at which we're creating, we're writing this definition. So as we have before, but I didn't mention, we use a method on output to format the policy. And what that does is it says, I know I'm going to have values at some point in the future. When I have those values, will you please inject them into here and allow me to have a formatted string. And here we have the data bucket ARN brought forward from when the data bucket has been created. And there we go. So we've created a policy. The next thing we need to do is have some code. Again, as for the Azure function, and it's more or less the same function code with a fairly thin wrap around it. I go and look in the publish folder, so that's a .NET publish. I create a zip from that. I have to pass configuration in for S3. We don't care about having the container name. The account name. We just care about the bucket ID, so we pass that in, and then it's the same quote server host as I used for the other one, which is a function running in AWS and isn't there anymore. That then gives me, for my Lambda function, .NET Core runtime with some code, with a handler, with the environment variables, all of that, and we're more or less done. So Pulumi up one last time. Now, normally I would expect to run deployments as part of my my build pipeline. I wouldn't expect to run them from my desktop, except for developer testing. So this time we say Pulumi up, we choose the AWS dev stack, and we say non-interactive. And yes, because we want to approve any questions that were asked. If you don't say yes, it will stop. So we get the same sequence in that it will do a preview first, and then it will do the actual create of 6 resources in this case. But it doesn't do the clever repainting of the terminal. It just runs straight through from beginning to end. And there we have a bucket with an ARN and a name, and then an AWS invocation ARN, so that we can call it from AWS tooling. Azure, we had to jump through more hoops, but it then exposed the function directly with a public HTTP endpoint. For AWS, if you want an HTTP endpoint, you have to do some more work. That involves more of those policy documents, and I completely couldn't get that to work when I was doing this demo the first time, and I haven't sorted it out yet. So what I can do is I can show you a couple of screenshots. This is the deployed function with the data bucket and the service host that I'm using, and I used the test invoke, which gave me an execution result, something like that, and it said in which Douglas Adams says that all opinions are not equal. Some are very great deal more robust, sophisticated, and well supported in logic and argument than others, which I quite like. Okay, so that was a made-up example based on real world. This is one last example, which is a real world example. It's real code, well, almost. I've changed some names. This is for Azure. It's written in Fsharp. It's getting a bit meta because it's some of the stuff we use to define the environment that we deploy into in Azure. I want to show you this because it turned out to be surprisingly straightforward. The problem was in knowing what to do in the first place, not really so much in actually doing it. So once I worked out what I wanted to do, it just sort of all fell into place. So big lump of Fsharp. Basically what I'm trying to do is I've got a little bit of DNS infrastructure that I need to set up specifically so I can send email from SendGrid. And then I've got some Pulumi infrastructure I want to set up, which is the storage, the backend storage that we want to use, a key vault so that we can have our secrets encrypted by something that we don't have to type in every time, and a couple of other bits and pieces that go with that. Each one of those returns a list of tuples that I convert to a dictionary, and for Fsharp, that dictionary is the list of things that get output at the end. So that's this. For Fsharp, we return a dictionary, where in C# we had annotated properties that were the outputs. So if we look at the the DNS bit, I want to create a resource group because you have to have a resource group. I want to create a zone for this domain name. So I set that up in this resource group. And then I want to add the domain validation for SendGrid to that zone. And when I've done that, I'm going to return the list of name servers for the zone, because I need to take those name servers and hand them off to a different piece of infrastructure where the DNS is registered. SendGrid requires 3 keys. So what I did here was create 3 tuple with 3 values that are the ones that we need to set up. And then I just iterated over those and made a record with the resource group and the zone. And making a record is that, which looks a bit horrible in this as it's wrapped. But what I'm saying is I want to create a CNAME record with the following argument. So let CNAME equal CNAME record, and then I don't care, so I just throw it away. So that's the DNS stuff for brains just stopped working. For Pulumi, we need a storage account. So the JSON I showed you earlier, that in GitHub in this repo, we store in a bucket in a blob in Azure, and that means that we're not trying to commit to changes to JSON when we're making deployments, which will be a complete pain from the build pipeline. So separating the backend out into blob storage, or better yet, to go and use Pulumi's paid for services, will take a lot of that stress away. So we have a standard storage account, which we call Pulumi Storage, standard tiers, all the usual things. And then we have then we have a container that we're also creating, and the container is for the platform. The platform is the name of the thing we're building. So all of my Pulumi, all of our production Pulumi code, Pulumi data, sorry, gets stored in the platform container. Then we have a number of users that need to work with Pulumi. So I have Tom, Dick, Harriet, and Jamie. And then we just do things that make sense. I need to get the IDs for those users so that I can talk to Azure about them. So we'd say the arguments are get the list of mail nicknames, pass those off to get users, invoke async, run it synchronously. And when I then end up with a list of object IDs, and I just map those object IDs to being inputs. So I end up with a thing that's an input and an object ID. I say that I have a group. The group is Pulumi developers. These are users that do Pulumi development. And I take that list of inputs, make it an input list, and hand it off to members. And then Pulumi goes off and talks to Azure and gives me a group in Azure AD of my users that are the ones that I want to do that. And this is where it's fun, because if we add another developer or more developers, we add them to the list, we rerun the code, and we're sorted. If somebody leaves, we take their name out of the list, we rerun the code, and we're sorted. We have a very limited number of uses for this at the moment, but over time I expect it to expand. In addition to the actual human users, we also need to have a service principal, which is a kind of sort of fake user, in order to be able to run the Pulumi code from Azure DevOps or GitHub Actions or anywhere else really. So we create a service principal. We use the same. We have a deploy app that allows the user to have permissions. So we've created the service principal. We need to give that service principal access, the rights to do things to our subscription. So we make it a contributor to the subscription. And then we create a key vault. The key vault, as I said, we're going to, as a secret in there, we need to enable some things to work. And there's a key which is then used to encrypt the Pulumi configuration so that any values that we don't want people to be able to see can only be seen with that key. Since we're creating a key and a secret, we need to decide what permissions we want to give them. So we have a list of permissions. We map that list to inputs. We have a list of permissions for secrets. We map that list to inputs. We create a vault policy, and it says that for the current tenant, for the developer group, they have these key permissions and these secret permissions. Similarly, I've done one for the service principal. It has exactly the same permissions. And then we create the key vault, and we say that it's got a name, that it's in the resource group, it's the standard SKU, it's my tenant. Soft delete enabled is a requirement. It has to be soft delete enabled now, didn't at the time I wrote this. And then the access policies are the list of the vault policy for the developer group and the vault policy for the service principal. And then I create a key and I stick that in the things, and enough already. The point is that this is all stuff that's very readable to a developer. It should make sense to you. I really barely touched the surface of what's possible, but this is all code, and hopefully code that you understand, whether that's C# or F# or Python or Go or TypeScript. And if you understand what you're writing the stuff in, then you only have to learn another library, and that's a lot less painful than having to learn a whole new system. So what have I missed? Obviously my layout's got wrong there. I've missed secrets, passing values between stacks, so stacks can have outputs, you can read them into other stacks. I've missed taking advantage of code to remove boilerplate and enforce standards. So there were quite a lot of steps to create a deployed function app, but those steps are the same every time. So we don't have all of those written out 6 times. We have them written out once, and we just pass parameters in. It's code. You can do the things that you do in code to make your life easier. Shiny new automation API, I forgot that. All of this was done calling Pulumi from the command line. One of the things they're adding is an ability to invoke Pulumi like a library. It exists in Go. I believe it exists in TypeScript. I haven't looked recently. It doesn't exist in .NET yet, so I haven't got to using it. There's an open question here as well, and I got that wrong as well. That's how to architect your stack, how to one stack is probably not enough. You're probably going to end up with a sort of a dependency tree of stacks. Now, we're not at a point where that's sufficient of a problem that we have to worry about it. Yeah, got this one wrong as well. So what potential issues do we have? The providers are separate from Pulumi, so you are dependent on the provider making changes, making sure that their API is up to date, Terraform updating their providers, and Pulumi then changing the providers that they set on top of Terraform. All of these things do actually happen quite quickly. Pulumi are very effective about in terms of getting their stuff updated as soon as they can. The Pulumi version revs almost continuously. In addition, they're introducing a thing called next-gen providers. The Azure next-gen provider does not go through Terraform, it goes straight to Azure using Microsoft's APIs. Those are generated automatically, and therefore they rev very, very quickly. Pulumi is independent of the cloud providers, but the cloud providers want you to use their systems, therefore they want things like Pulumi to work. So that's not necessarily a huge issue. And the last is the documentation problem. This is almost an impossible problem. The CDK has the same one in that they're very good at documenting. Excuse me, they're very good at documenting the methods and the parameters, not so much about exactly how to use them in a particular circumstance. You still have to go back and work out how things are constructed. That said, Pulumi, at least for Azure, have Pulumi generators, so you can go and get the ARM from the portal, download it, magically translate it into Pulumi code, and then work forward from there. If you're still interested, there's a whole load of resources. The whole of this presentation is on GitHub, GitHub recumbent DDD 2020. Pulumi's website is pulumi.com, but also Pulumi is an open source tool, so you can go on there and see the code, and you can see the examples. There is a Pulumi community Slack, which has active users. I'm on Twitter as recumbent. You can ping me and I will respond. In theory, I have a blog. I'm still kind of working to get that up to speed. And for the time being, this is on Gitpitch, except that A, it's broken on Gitpitch, and B, Gitpitch is going away, which is very sad. If you have questions, I'll happily answer them. Start typing now because you're some seconds behind me. So if anyone has survived this long, thank you for your attention. I've been working with Pulumi for a few months and I've still got huge amounts to learn, but I'll answer any questions I can. I'll be here as long as people have questions to ask, and I will be on Twitter. And I would very much like to have seen you all for a social beverage afterwards, but this being what it is, we can't. Thank you very much for listening.
Hey James, just Mike dropping back in. Thanks for that. Hey, that was really cool actually. How are you? How do you find companies who might be considering migration from, say, if they're using ARM or Terraform or something already? Is there like a good migration story if they wanted to try Pulumi?
Well, honestly, I can't answer that. Well, actually, let's try it a different way. It's not a problem I have because I arrived at a company that had already decided to do that. So my company started off straight away. But it's a good question. You can, first of all, as I said, they have created recently a tool that will allow you to do to generate code from an existing ARM template. I'm not sure about other environments, but I know that there's tooling for that. Secondly, you can tell Pulumi that you want to import existing resources. So there's a pattern that allows you to import existing resources. Hang on, what I need to do here is I need to share tray. Right, okay. There's a pattern that allows you to take existing resources, create them. It will tell you if the resource that you're trying to import matches the definition that you've got, and when it does, it will then let you do that. Beyond that, the other way that you might do it is you can do, you would roll over from existing projects to new projects, and the new projects would adopt the new stuff and you just leave the old ones alone.
Yeah.
If you're running in a microservices environment, and this is really very nice for that kind of environment, then you just say, well, I'm starting a new project. The new project is going to do the new thing, and we'll not worry too much about the old stuff unless and until it becomes a problem. There you go.
I guess with it being desired state, though, the idea of importing existing resources means you're not like having to rewrite the entire script, are you?
No, I haven't tried it.
Part of it. Yeah.
Yeah, I haven't tried it. In theory, let me get this straight. Okay. If Pulumi doesn't know about something, it will ignore it. So it won't delete things it doesn't know about. So it will only, if you change your stack or destroy it, it only destroys the things it knows about. So if you've got infrastructure, you've got things that you haven't told Pulumi about, it basically ignores it. That's different to say Cloudformation, because Cloudformation attaches the resources to the stack. Clearly, if you delete the resource group and you've got things in the resource group, bad things will happen. So, but there are protections as well that you can put in to stop you deleting things you don't want to.
Cool. Have you got any tips for people who want to kind of start checking out Pulumi, of places to go to like learn about some of the skills that you would pick up? There are quite a lot of people who are enthused about it. So this is the second presentation on Pulumi today. So I haven't seen the other one because I was frantically writing mine. But we can go back and I suggest going that. You can ask on the Pulumi Slack. That's good. Pulumi themselves have a fair chunk of resources knocking around. They also have some very enthusiastic members on their team. So there's a guy called Paul Stack, who is a continuous delivery and infrastructure enthusiast, as well as a good engineer, and he will happily bend your ear for as long as you want on the subject. But I would start by going to Pulumi.com and looking at the docs there, which are decent, and they have some walkthroughs. And then I'd also go to
Pulumi GitHub, where you can look at the examples. And you can play with all of this for free.
Yeah.
As I said, there is a paid-for service which we haven't investigated, which I really want to use because it would take some stress away. But you can do all of this for free on your own machine without having to bother anybody else.
Is there any particular use cases with Pulumi that you're going to be looking at learning yourself next?
I'll answer that with an entirely different answer. The problem we've run into is that Azure AD isn't particularly well covered. So everything that we're running is fine, but the security infrastructure that we're trying to wrap around it, not so much. And as it's finishing time, excuse me. Awesome, right. So the only real difficulty we've run into, or the real difficulty we've run into is where there isn't Terraform support for what we want to do. Where there is Terraform support, absolutely everything. The areas we want to expand into, we've got a very small amount of stuff done with our Azure DevOps system. We've got one repo created that way. We want to import all of the repos that we use into Pulumi so that we can apply the same sets of rules for pull requests and protected branches and things in a consistent manner. The DNS we're using, I've got one small piece of DNS. I'd like all of it. We are adding users for our platform. We're at a very pre-release stage, so it's a bit vague. So yeah, I hope that kind of answers that.
Cheers. There's a question from Robin who asks what your thoughts are on Pulumi. Will Pulumi survive given Terraform's head start?
Yes, because it's about it comes back to this cognitive load question. So if you think about build tools, we have Cake and Nuke for C#, and we have Fake for F#, and there are, if I go off into other languages, there are, in every single language has its own build tool, because if you use PowerShell, for example, Saki as your build tool, and your developers are C# developers, it's different enough that they go, no, we'll end up having somebody who understands builds and nobody else does. So the value in Pulumi, more than anything else, is that you're using a language that you as a developer understand. And that means that you don't have to learn something new, and Terraform is effectively something new. And because you don't have to learn something new, you can take the amount of the percentage of cognitive load that would have gone to learning that and apply it just either to getting infrastructure right or to other parts of the problem space. So yeah, the guys who are doing this are bright and enthusiastic, and pretty much everybody I've talked to about it says, actually, I like that a lot. I mean, I'm talking about it because I like it a lot. So there you go.
So it's really kind of like it's an extra lowering of the cost of ownership and support cost for that stuff. Frees you up to
yes.
other more value tasks.
Yeah, if you believe that people should own their stacks end to end, then yes, absolutely. And I do believe that people should own their stacks end to end. So
cool. I think that looks like it's the last of the questions there, James. So huge thanks for that session. It was really interesting. It's good to get a little bit of a view. I know we were chatting about it a little bit earlier, but I've done quite a bit with Terraform, and I hadn't realised Pulumi was more of the infrastructure side of things. I thought it was a bit more of like a kind of a pipeline alternative. So it's really good to get that clear for me. And I'm sure other people would have got that good benefit as well. Yeah,
it's the thing that you run in your pipeline rather than the pipeline itself. And in much the same way that the build tools like Fake or Cake or whatever are independent of the pipeline you run in. So you can run Pulumi because it's just a command line or ultimately just an executable. You can run Pulumi in Circle CI or Azure DevOps or GitHub Actions or AWS's, I can't remember, whichever you choose, or GitHub, TeamCity or Jenkins. I mean, it will run in any of those contexts, which means that you can build out your pipeline in a way that makes you comfortable.
Awesome. So any last things you'd like to say, James, before we wrap up?
No, I would just thank you all for listening. It's been fun, and I'm looking forward to going and watching a lot of sessions over the Christmas break.
Yeah, some good ones, isn't there?
Yeah.
So on behalf of the audience, thanks for presenting today. Hope everybody has a really good time over Christmas and stuff, and I hope everybody enjoyed DDD today.
Cheers.
All the best. Thanks, James.